Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going and inspired. And if my videos are important to your studies, don't forget to subscribe. A simply supported beam, 20 meters long, supports a dead load of 6 kN per meter and 5 moving concentrated live loads shown. Determine the absolute maximum combined shear, the maximum combined moment at the center, the absolute maximum combined moment. So for the absolute maximum combined shear, due to live loads, it is either reaction at the left support or reaction at the right support. Then we combine it with the shear due to dead load, which is uniform, so WL over 2 would be the reaction due to dead load. Or you use the influence line, W times area of the influence line, which is 1/2 of L times 1, because the maximum ordinate is 1 over the support. It will still give us WL over 2. Same is then for a maximum combined moment at the center, uh, we can easily analyze that, and the absolute maximum combined moment also, using the criterion. So this is the figure. So imagine loads move from right to left, and we want the reaction at A maximum. Let's find it first, and let's compare it with the maximum value at B reaction, and we can find the absolute maximum shear due to live loads first. Then we combine it with dead load, because the shear or shear due to dead load or reaction due to dead load will be fixed. So load 2 over A, the criterion, by the way, delta VR is WH over L minus P1 only, because we are computing for the reaction, and there will be no incoming load because 3 plus 4, 7 plus 5, 12 plus 5, 17 is less than 20. So delta VR equals WH over L minus P1. That's our criterion. So load 2 over A, then W would be 30 plus 40 plus 35 plus 25. P1 is 20, H is 3. 70, 100, 130. So delta VR is 130 times 2 times 3 over L, 20 minus 20. And the sign is negative. So that means preceding position, load 1, will 1 over A satisfies the criterion. Then next, delta VR equals 100. This is load 3 over A. Load 3 over A. So the W would be 40 plus 35 plus 25. That's 100. H is 4 and P1 is 30. Minus 30. So it is also negative. So let's continue. So it does not satisfy the condition because it is negative. So that means will 2 over A also satisfies, because preceding position, load 2 over A was positive. Load 2 over A was positive. Now that load 3 over A, so there will be minus P1, that's why it's negative. Will 2 over A also satisfy the condition, preceding position. So let's evaluate RA by these two possibilities. So if P1 is over A, then RA cannot be computed. So RA times 20, summation moment at P, equals 20 times 20 plus 30 times 17. 20 minus 3 is 17. 17 minus 4 is 13, so plus 40 times 13. 13 minus 5 is 8, so plus 35 times 8. 8 minus 5 is 3, so plus 25 times 3. So RA1 equals 89.25 kilonewtons. If load 2 is over A, so RA times 20, summation moment B. RA2 times 20 equals 30 times 20 plus 40 times 16. 20 minus 4 is 16. 16 minus 5 is 11, so plus 35 times 11. 11 minus 5 is 6, so plus 25 times 6. And RA2 is 88.75, so it's less. Next, let's solve for RB. Load 4 over B first. So delta VR is, if load 4 is over B, then this is our P1, H is 5, and W would be 35 plus 40, 75 plus 50, 125 times H 5 over 20 minus 25 when load 4 is over B, and the sign is positive. Then load 4 over B, load 3 over B. Load 3 is over B, our P1 would be 35, our W would be 40 plus 30 plus 20 is only 90 times 5 over 20 minus 35, and it is negative. So that means preceding position, load 4, wheel 4 over B satisfies condition. So we will evaluate this just for RB because wheel 4 over B, this is great comparatively, but this gives maximum perhaps because the 40 kilonewton, 30 and 2 will still be on the span. Whereas if load 3 is over B, there will be fewer loads on the span, and definitely it will not give maximum reaction at B. So this is possible, 35 over B, because it satisfies condition also. So summation moment A equals 0, RB times 20 equals wheel 4 is over B, so 35 times 20. This is over B. Then plus 40 times 15, because 20 minus 5 is 15. 15 minus 4 is 11, so plus 30 times 11. 11 minus 3 is 8, so plus 20 times 8. Solving for RB, R sub B is 89.50 kilonewtons. This is greater than 89.25 and greater than 88.75. Therefore, this is the absolute shear absolute maximum shear due to the live loads. So we will use this combined with the dead load. The dead load reaction at B due to dead load is WL over 2, or W times area of the influence line for reaction at B. So it will give us WL over 2 also. So maximum shear absolute is 89.5 plus due to dead load WL over 2, or 1/2 WL. So therefore, the absolute maximum combined shear is equal to 149.5 kilonewtons. Then the maximum combined moment at center, so criterion delta M equals W over L minus W1 over L over W1 over A, which is L over 2, equals 0. So delta M is W over 20 minus W1 over 10 equals 0, or simply W over 2 minus W1. Since the heaviest load is 40, load 3. So this is definitely the load that will cause maximum bending at the center is 40 kilonewton load. And some of the loads will be on the span for this case. So the resultant, because this is already 10 and 30 times 4, 120, 20 times 7, 140, 140 plus 120, 260, compared to 35 times 5 and 25 times 5. So the resultant will be somewhere here and all the loads will be on the span. So delta M equals 150 over 2 minus 90. That is when load 3 is just to the left of the center line. So W would be 50 plus 40, 90 plus 60. All the loads are on the span, 150. So 150 over 2 minus 90, where 90, because load 3 is just to the left of the center line, so it is part of W1. So 20 plus 30, 50 plus 40, 90. So it is negative. So that means load 3 over the center line satisfies the criterion. So let's also evaluate load 4 because this is also heavy. So when load 4 is just to the left of the span, 20 kilonewton load will be off span. So W1 would consist just to the right first. So let's evaluate. This is load 3 over the center line. So let's solve for RA. RA times 20, summation moment about B equals 0. RA times 20 equals 20 times 17. 7 plus 10 is 17. Plus 30 times 14. Plus 40 times 10. Plus 35 times 5. Then 25 times 0 not included. So RA is 66.75. Then the maximum moment at center line 1 possible is RA times 10 minus 30 times 4 minus 20 times 7 is 20 times 7. So it is equal to 407.5 kilonewton meter. So M center line max is 407.5 plus 6 times 20 square over 8. WL square over 8. Take note, for the dead load, the maximum moment at the center is WL square over 8 for the dead load. And this is for live load. Therefore, M's center line maximum equals 707.5 kilonewton meter. So we will not consider load 4 anymore. Definitely it will not give us maximum value. And finally, absolute maximum combined moment. So for absolute maximum moment, it occurs under wheel 3. When wheel 3 and the resultant of the loads are positioned equidistant from that center line, the center line will be here, and R is 150 kilonewtons. The distance between R and 3 is E, and this is the center line by principle. So 150 times E equals 35 times 5 plus 25 times 10 minus 30 times 4. This is our reference, minus 20 times 7. So E is 1.1 meter. Therefore, E over 2 is 0.55. So let's now position load 3, wheel 3, and R and the loads on the span to give us a clear picture. So the distance of wheel 3 from A is 10 minus half of E, 10 minus 0.55, so 9.45. This is the distance of R from right is also 9.45, where 9.45 meters is 10 minus E over 2. E over 2 is 1.1 over 2 or 0.55, so that's why that's 9.45. That distance is also 9.45. So computing for either RA or RB, but let's have RA, so that the absolute maximum moment due to live loads is RA times 9.45 minus 30 times 4 minus 20 times 7. So RA times 20 equals 150 times 9.45. So RA is 70.875 kilonewtons. Then the absolute maximum moment due to live loads is 70.875 times 9.45 minus 30 times 4 minus 20 times 7. So M absolute due to live load is 409.77 kilonewton meter. Now how about to combine the absolute maximum moment? So imagine the dead load is here. So we just compute RA. RA due to uniform load is WL over 2, and we just sum up moment about load 3, and it is RA WL over 2 times 9.45 minus the moment of the dead load, which is 6 times 9.45 times moment arm 9.45 over 2. So M absolute dead load is 6 times 20 over 2. That's the reaction at left, WL over 2. And we take moment about load 3, considering forces to the left, not these live loads but the dead load only. So times 9.45 minus 6 times 9.45 times 9.45 over 2, the moment arm. So moment absolute due to dead load at is 299.09. The absolute is at the center, but this is moment at under load 3, which is close to absolute. That's why we combine these two, because there's a big possibility that this will be greater than moment at center, because this is absolute combined moment. So therefore, M absolute max is 409.77 plus 299.09, and it is equal to 708.86 kilonewton meter. So we add up this because this is greater than the moment at the center, which was, I think, 707.5 only. So that's it for this problem.